Santham Academy. Welcome to Digital Kaksha. To get updates on new videos, click the subscribe button and the bell icon.
Hello students, today let us discuss about the topic heating effect of current. In this topic, the explanation is given about the working of the heating devices, that what is the basic principle behind the working of the heating devices. Before coming to the explanation part, I would like to discuss some daily life examples with all of you. We all have observed that when the fan works for a longer period of time, the blades are heated up. Even the regulator of the fan, it is also heated up. Similarly, when the electric iron is switched on, it also gets heated up after a certain period of time. Why it is happening? This is because when these devices are used in the closed circuit, certainly they are receiving the current, and some part of the current is used up for the production of the heat energy. Now, how to calculate this heat energy? How to get the formula for this heat energy? For that, we are taking the help of the formula of the power, that is work done upon time taken, which we have studied in class 9. In the concept of electricity, the work is calculated for the movement of charge Q through the potential difference V. Now, this charge is the charge which is present in any of the conductor in the form of free charges, and these free charges are only responsible for the flow of current in any of the circuit, and this work done will be divided by the time for which the charges are flowing through that potential difference region. So, here the power is given as Q into V upon T. If I will take Q upon T together, certainly it can be written to be equal to I. So, I have got the value of power to be I into V. Since we have to calculate the heat energy in this formula, so in this step, in place of power, I have to substitute I into V. The unit, the SI unit of work done and heat energy is joules. So, in this formula, the numerator can be replaced by the heat energy, which is denoted by H. So, this way, the formula for H is obtained as VIT. Now, according to Ohm's law, we know that V is equal to I into R. So, if I want to eliminate V in this formula, I will get the formula of heat energy as I square RT, where I is equal to V upon R. If I will eliminate this I now, so I will get the formula, the third formula for heat energy in terms of V and R as V square upon R into T. There is a significance of this formula of heat energy I square RT in the topic which is said to be the Joule's law of heating. So, what is the statement for Joule's law of heating? According to this law, the heat energy which is associated with the device of resistance R through which the current is flowing for a certain time T, the heat energy which is represented as H is directly proportional to the square of the current flowing through that device, directly proportional to the resistance R of that device, and also directly proportional to the time for which the current flows through that device. From these three numbers 1, 2 and 3, I can get the mathematical relation for this law, that is H is directly proportional to I square RT. According to Joule, when this proportionality sign is removed, in the formula there is equal to sign, and this way the complete formula for the heat energy, or even we can say the formula according to Joule's law of heating, is obtained as H is equal to I square RT. Let us now study about the practical applications of heating effects of current. The first application is that alloys are used in heating devices. The resistance of alloys is very high due to the high value of the resistivity. Because of that reason, the amount of heat which is produced in alloys is very high according to the formula H is equal to I square RT, or even I can say due to the direct dependency of heat energy on the factor resistance. So, when large amount of heat is produced in the alloys, that is the reason that the alloys are used in all the heating devices, whether it is water heater, it is room heater, geyser, electric oven, etc. The second application for the heating effects of current is the device which we use in the domestic circuit and is called as the fuse. Fuse, it is a wire which is made up of a substance with low melting point. The wire which brings the current to all the appliances in the domestic circuit is called as the live wire. The fuse is connected between the live wire and the electric appliance. The role of the fuse is that in case of the extra amount of current, when it is flowing through the live wire accidentally, the fuse protects all the appliances by not allowing that large value of the current to allow to pass through the appliances. So when we are saying that the fuse is made up of a substance with low melting point, in that case, according to the formula of heat energy, that is H is equal to I square RT, when the amount of current or the magnitude of the current is too large in the circuit, in the wire which is carrying the current to the appliances, certainly this value of I, it increases in the formula, because of which the value of the heat energy is also increased. At this large value of heat energy, the fuse wire, it melts. Now when the fuse wire melts, certainly the contact of the appliance with the live wire, it breaks, and this way, by melting itself, the fuse doesn't allow the large value of the current to reach to the appliances, and hence it protects the appliances from any kind of damage. This is the reason that the fuse is also called as the safety device in the domestic circuit. The third application of heating effects of current is to understand the use of tungsten in bulb filaments. We know that in the working of the bulb, the electrical energy is converted into the heat as well as the light energy. Tungsten, it is a metal with very high value of melting point, that is 3380 degrees Celsius. With this high value of melting point, tungsten has got the capacity to tolerate the large amount of heat which is generated. Now when the tungsten is getting heated up due to the large production of heat, it starts glowing and it emits light. The gases like nitrogen and argon are filled in the bulb to prolong the life of the filament of the bulb. The next topic which is to be studied is electric power and electric energy. First, let us discuss about the term electric power. So, electric power is the rate at which the electric energy is consumed or dissipated. The SI unit for this physical quantity electric power is watt. The higher unit for the power is kilowatt. Now, we know that 1 kilowatt that is equal to 1000 watt. The formula for the power can be understood as P is equal to V into I. This is the formula which we have written from the topic where we have derived the formula for the heat energy. So, power can be written as V into I. By using Ohm's law, when V is to be eliminated in this formula, the formula for power can also be written as I square R, and the third formula for the power is written here in terms of V and R, that is equal to V square upon R. In order to understand the definition of SI unit of power, or even I can say in order to understand the definition of 1 watt of power, if I am using this formula, for getting the power to be equal to 1 watt, certainly I need the potential difference of value 1 volt and the current of value to be 1 ampere. With the substitution of these values, I can define 1 watt as the power which is obtained when 1 ampere of current flows through a device across which the potential difference is applied to be equal to 1 volt.
Thanks for watching. If you like this video, make sure to like, share and subscribe for more.